Hey everyone, welcome back to Brainstorm. This is Python for NCEA. Now, in this video, we're going to take a look at reading text files. So let's get into it. So if I go over to my file explorer, you can see that I have got two text files. Now, for our learning purposes, we're going to be taking a look at the fruits text file. Now, when we are reading from text files in Python, for our level and for our sake, we're just going to make sure that the text files are in the same location as the Python file. Okay, so you can see that they're in the same folder here. Let's take a look at what's inside the fruits folder. So what we can see is we've got a bunch of fruits separated onto new lines. So we've got apple, banana, pear, grapes, mandarins, oranges, and watermelons, and they're all separated onto individual lines. Now, you can see that apple actually has some excessive amounts of spaces which we will not want to include in our actual when we process this text file. So let's take a look at how I'd actually process the text file. So there's a couple of ways that we can do it, but we always want to start by opening the text file. So what we're going to do is we're going to create a variable. Let's call it fruits. So fruits is equal to, we're going to write open, and we're going to have our parentheses. And inside of the open, we need to include two things. The first thing is the name of the text file in as a string. So the name of my text file was fruits.txt. So we're going to write fruits.txt. We're going to put a comma, and then we're going to have another string, and the string can either be read or write. For our purposes, we're only looking at reading text files, so we're just going to put R for read. So this is going to open the text file, but it's not going to do anything else. So the next thing we want to do is we want to read that text file. So if I go fruits is equal to fruits.read, and .read is a method, and so we have our parentheses there. And now if I print fruits and click F5, you'll see that it prints out what's in that text file onto the outer shell, and you can still see that we've got those spaces there. So this is probably not that useful for us since we don't want to just print the text file onto the shell, but we probably want to be able to process the information. So usually we'd want to store this information in something like a list. So let's look at how we would convert this into a list. So let's create a new variable called fruits list. And so we always need to start by reading the text file. The next thing we want to do is we want to convert this into a list. So one way that we can do that is by using the split method. So we can do fruits.split, and .split is a method, so we have our opening and closing brackets as well. And let's have a look at what happens if I print fruits list. Well, as you can see, it's converted everything that was on individual lines into an individual element in a list, and you can see that it's got rid of those spaces there. So this is a really cool way to convert, an easy way to convert this text into a list. Now, there's obviously a couple more ways that we could do this. Another method that is maybe not as simple, well, maybe not necessarily as simple, but might involve some more steps, is using, so instead of having .read and then .split, we could do some things on the same line. So what we could do is we could say fruits_list is equal to fruits.read, and then we put .split lines. So what this is going to do is it's going to read the file, and then it's going to split all the lines into one list, so where each line is its own element in the list. So if I print fruits list now, what do you think will be the outcome? Well, it's going to be almost the same as this, but it's because we're splitting depending on each line, it's also going to include this spare white space here. So if I said that and run it, you'll see that it includes all that white space there, which is a little bit unnecessary. So what we'd have to do in order to get rid of that is we need to run a for loop. So let's say for I in range the length of fruit lists, and then I'd have to go fruits list I is equal to fruits list I, And to get rid of white space, we use a method called .strip. So .strip, and this will get rid of any leading white space or /n, which means new line characters. So if I save this and run it now, only now we get what we had before, and I had to run a for loop in order to do that. So in this scenario, doing it with the 2 lines was a little bit easier. Now, something that's good practice is always to remember to close our fruits file once we've finished reading it. So what we do is we write fruits, because that's where we've opened it, and we would want to go .close. That's going to close our file. So once we've finished reading the file, which is happening at .splitlines, we would close the file there. Okay. So if I say that and run it, you see nothing changes. It's just that it's going to close that file. So that's a really good habit that we would want to keep. But you can close it at any time. So next thing we can do is we can do pretty much the same thing using something called list comprehension. Now list comprehension is quite advanced, so we won't go through exactly what list comprehension is. We'll just look at one technique, which is going to make it a little bit easier for us. We can do everything in one line. So what I'm going to do is I'm going to comment out. Oops, I'm going to comment out all of this stuff here, and we're going to move this opening the file into this part here. So we've just opened the file. The next thing we're going to do is use something called list comprehension, which converts something into a list. So we're going to create a variable called fruit list. We're going to set it equal to a list. Now in the list we are going to write the following. We're going to write x.strip for x in fruits. Essentially what this is going to do is it's going to make a list from the file, or from all the text read in fruits, and for every line it's going to strip it. So it's going to remove any leading white space or new line characters. So if I print fruit list now, and I've made a spelling mistake. So if I print fruit list now, you can see it prints out the required output, and it only required me to write literally one line. So after that, I'd probably want to close my file, so I go fruits.close, and as you can see, it's giving us the necessary output required. Alright, let's look at our application question for today. So question 1, in the UFC, which is like cage fighting, stats are recorded on significant strikes. Write a program which takes significant strikes from a text file and interprets the results. Now, the structure of the text file is as follows. Each significant strike is given by a 2-letter word separated by a space. The first letter corresponds to the color of the fighter who was awarded the significant strike. R is equal to red and B is equal to blue. The second letter corresponds to the target hit, so we could have 3 different targets. H is equal to head, B is equal to body, and L is equal to leg. The name of the text file is ufc.txt. Now, the data recorded was taken from UFC Fight Night Poirier versus Hooker. Here, Poirier belongs to the red corner and Hooker belongs to the blue corner. Calculate the percentage of significant strikes landed to the head, body, and leg targets by both Dustin Poirier and Dan Hooker. And we want to print the results as follows. So we'll print first Dustin Poirier's percentage of significant strikes and Dan Hooker's percentage of significant strikes. Now note, you should make use of any tools that you've learned this far. To complete the question, you may find for loops, lists, and dictionaries particularly useful. So before we start, let's have a look at what the text file looks like. So this is the text file here, and you can see that I've put random lines, and as well as we've got some leading white space in there, and I've just clicked enter a few times to put random amounts of the targets onto random lines, but you can see that for each strike, each significant strike, so these are each 2-letter combo is a significant strike. B is for the blue corner, and H means that's where the hit target was. If we look at this one, this is, for example, RL here means red corner, leg hit. Okay, so you can see that they're not all in the same order, so you don't have all of the BH followed by all of the RH followed by all of the BL, for example, because in a fight, of course, you're getting random strikes. So you might get blue head, red leg, blue body, red body, so on and so forth, right? So it's all random. So what we want to do is we want to convert this here all this text here, and we want to essentially calculate percentages. So of all the strikes thrown by the blue corner, how much percent was on the head, body, and leg, and the same thing for the red corner. Okay, so have a go, and then I'll go through how I would do it. Right, so let's get into it. So first thing we want to do is we want to open that text file. So we're going to create a variable called UFC. Let's set it equal to open, and we want to open that text file. So that's ufc.text, and we want to read it. So we put comma and then the string R. So that's going to read the text file. Sorry, it's not going to read the text file. It's going to open the text file. We also want to remember to close that text file. So why don't we just close it now and do everything else in between. So the next thing we want to do is we want to read the text file. So let's just do, let's call it sig strikes is equal to ufc.read, and we are finished with reading. We're finished with the text file in general. So we close it. Let's print the sig strikes. So let's see what is the output. So you can see the output is essentially what exactly was in the text file, which is it's not quite what we want, right? So in that case, what are we going to do? So what we're going to do is we're going to say sig strikes is equal to sig strikes dot split. So if we print that now, let's see what happens. So what we can see is it looks like everything has been split. Everything seems to have been split correctly. So I don't see any trailing white space or new line characters or anything like that. So it seems like every strike has been converted into a list. So that means it's going to be quite easy for us to work with it. And so, for example, I can also now print the length of that list. So sig print the length of 6 strikes. And now, so we've got 308 significant strikes in total. Right? So we can already do some analytics with it. But we're not really interested in how many strikes there are. We're interested in percentages for each fighter. So what's the next thing we're going to do? Because we want to know the percentage or the number for head, body, and leg for each fighter, we're going to create 2 dictionaries. Now we could do this with lists if we wanted to. I'm going to use dictionaries, but personal preference of what you want to do. So I'm going to create 2 dictionaries. I'm going to call one the Poria dictionary. So Poria dict, and let's set it equal to an empty dictionary. Actually, we don't want to set it equal to an empty dictionary because we already know what the keys are. The key is head, so h is equal to 0. And in dictionaries, we don't actually put equals to, we put a colon and we say h maps to 0. Then body currently maps to 0 and leg maps to 0. So what we're saying is that there's currently no head, body, or leg kicks. Or leg hits, sorry. We're going to do the same thing for the hooker dictionary. So hooker dict is equal to head is equal to 0, or head maps to 0, body maps to 0, and leg hits map to 0. So this is our dictionary currently, or dictionaries currently. What we're going to do now is we're going to loop through this list and add the respective things to these lists. So what we're going to do is we're going to loop through the sig strikes. So for I in sig strikes, and what we want to do is we want to say if I is equal, well actually if the first index of any strike is blue, so that would be if I naught, so if I index 0 is equal to blue, then what happens? So who's in the blue corner? Hooker belongs to the blue corner. So if I naught is equal to B, then what else? Then what do we want to do? Well, next thing we need to do is we need to check what the second index is, or what the second letter at that second index is. Okay, so what we'll say is if I1 is equal to H. So if it's a head strike, what we want to do is we want to increment the hooker dict at key H by 1. So what we'll say is we'll go hooker dict at H, and we want to increment that value by 1. Okay, else if I1 is equal to a body hit, then hook addict at key H should be incremented by 1, and else if I1 is equal to leg, then we're going to increment the hook addict at the leg by 1, and this should be hook addict at key B, so head, body, leg, and we're incrementing all of those by 1. Okay, if it is red, so if the strike at index 0, so if the letter at index 0 is actually red, so else, what do we want to do? Well, we also need to check if it's a head, body, or leg strike. So in favor of Poirier. So what we'll say is if I1, we're actually going to essentially copy this. This is exactly the same code. The only thing we're doing is instead of hook addict, we're adding it to Poirier addict. So Poirier addict, add Poirier addict. Okay, so now we've got 2 dictionaries. So hopefully this will add to our dictionaries. Let's print both Poirier addict and hook addict to check if it's working, because I potentially might have made a mistake or something. So Poirier addict and hook addict. Okay, name error, name H is not defined. What a classic mistake. So this is obviously meant to be a string, but I have not defined it as a string. So all of my keys should be strings. So H, B, and L are all strings. And we'll do it for hook addict as well. In fact, we'll just copy and paste it to make things a bit faster. Save that and run it. And now you can see for Poirier, he had 131 head strikes, 20 body strikes, and 2 legs. And for Dan Hooker, he had 98 head strikes, 36 body strikes, and 21 leg strikes. So just looking at the data, we can see Poirier was much more precise to hitting the head, and Dan Hooker was more of an all-round. So he had a way more leg strikes and body strikes compared to Poirier, but Poirier had significantly more head strikes than Hooker. Now again, that's cool, but we still need to answer our question. So we need to calculate our percentages. So I'm not going to print out the 6 strikes. So we're just going to print out the dictionary for now, so we can see what we're dealing with. So what's the next thing we need to do? Well, we need to calculate the percentages now. So how do I do that? Well, what I'm going to do is I'm just going to start printing out the values that I need. So let's do Dustin Poirier first. So we're going to print Dustin Poirier landed, and then we're going to print what he landed. So print dash X%, and because we're going to change the X depending on what the value is, we're going to put curly braces to use dot format. So curly braces % of significant strikes to the head, and we're going to use dot format. Now, how do we calculate the percentage of strikes that he landed? So we need to use the values inside of the Poirier dictionary. So what we're going to do is we're going to use so we're going to access Poirier dict, and we want to get the head strikes, so we're going to access key H, so the string H. And what do we want to do when we access that? So that's going to give me the total number of head strikes, and we want to divide that by the total number of strikes that Poirier did. So we want to obviously divide this by the total number of strikes by Poirier. So how do we do that? Well, we're going to create 2 new variables for both Dan Hooker and Dustin Poirier. So we'll say Poirier sig strikes, and we're going to get the total amount of significant strikes. So the way that we'll do that is we'll find the sum of the Poirier dict dot values. So this will get all of the values from the Poirier dictionary and sum them. So that'll give me the total amount of strikes from Dustin Poirier, and we're going to do the exact same thing for Dan Hooker. So we'll go Hooker sig strikes is equal to the sum of Hooker dict dot values. So we can actually print these, or we'll print one just for an example. So print Poirier sig strikes. So you can see he did 153 strikes in total. So we want to divide this Poirier dict. So that's going to give me the strikes at the head we're going to divide that by Poirier sig strikes. So that'll give me a decimal, and then we're going to multiply that by 100. So this will give me 85.62% of Poirier strikes landed to the head, which is an enormous amount. Now this is a little bit untidy, so let's round it to 2 dp. So the way that we'd do that is we need to use the round function. So we'll say round, we'll put brackets around the necessary places, and we'll put a (2) after the calculation is done to say round this to 2 dp. So if I save that and run it, you'll see, well, alright, sorry guys, so what happened before is I put the 2 down here, I think, but it actually should have been in this this bracket here, so it should have been next to this times 100 here, so that will round it to 2 dp, so we get 85.62% of sig strikes landed to the head. Okay, we're going to want to do this for both the leg and, the body and leg shots. So we're going to print this again. This time, each time we're interested in something different. So we're interested in body and leg shots for the other two, and we'll change this to say to the body and to the legs. So if I save this and run it now, we'll get all the significant data we need. So 85.62, 13.07, and 1.31. And hopefully that will sum to 100%, given the rounding. It might be a little bit off, but that's okay. So that looks about in the 100% ballpark. We're going to do the exact same thing for Dan Hooker now. So I'm not going to rewrite all the code. I'll just copy this and then make the adjustments when necessary. So instead of Justin Poirier, we're going to look at Dan Hooker. So we'll say Dan Hooker landed, and instead of using the Poirier dict, we're interested in the Hooker dict. So Hooker dict, Hooker dict, Hooker dict. But this time we're not interested in Poirier's significant strikes, we're interested in Hooker's significant strikes. So we'll say Hooker sig strikes for all 3 as well. And we should have a space in between those, so we'll print an empty line. Okay, so, and we should comment out these lines because we do not want them in our final output. And as you can see now, we've got Dustin Poirier landed 85.62, 13% to body, 1% to the legs. Dan Hooker landed 63% to head, 23% to body, and 13.5% to the legs. So we've used our knowledge from all the videos prior to essentially come to this statistical conclusion. But how do we know if it's right? Well, let's actually check on the UFC website. Alright, so here we are on the UFC website, and this is actually a recount of the fight. So you can see Poirier won by, I believe it was unanimous decision. Yeah, it looks like it was. So what we're interested in is this here. So landed by target, how many significant strikes? So we can actually double check if we got it correct. So 85% to head, 13% to the body, and 1% to the legs. So obviously they've rounded the ads a little bit differently than us, but as you can see, 85, 13, 1. So it looks like that is looking good for us. And for Hooker, 63% to the head, 23% to the body, and 13% to the legs. So as you can see, our data matches what the UFC have got there. So we've actually completed some great statistical analysis there. So you can see this is actually some real world application question here that we've just completed. Oops. So that's it for today's video. I just had one nice long question. I hope you enjoyed it. Leave a like, subscribe, and I'll see you guys in the next video. Cheers.